Hello everyone, this is Matthew Basan Thomas from Trainfirm. Today we will discuss on time series and forecasting methods using ARIMA method. And this video is going to be specifically around how to perform ARIMA using Rstudio. In my previous video, we had discussed on how to do ARIMA using mini tabs. So all the basics of ARIMA, the theoretical part has already been discussed there. So I wouldn't really be covering much of theory in this video. We would straight away go and see how we can do that in Rstudio. So in case if you have any doubts, any questions in terms of the basics, I would recommend you to go back to my previous video on time series and forecasting ARIMA using Minitab. It covers everything. We've spent quite a lot of time in discussing about the basics, so I'm sure that you would be finding that very helpful in terms of understanding the basics. Okay, so let me move ahead. So just to give you a recap, we have considered ARIMA, when to use it, objective, what are the different terms in ARIMA, and also how to make the data stationary. We have discussed this at length. We also did talk about how to do an analysis, how to step-by-step procedure of completing an ARIMA both. This is the generic thing, it can be applied. The steps remains the same, even if it's Minitab or if it's SPSS or if it's R. Today we're going to discuss on R. So the steps will remain the same. Okay, now that I've come to the slide, even before we get started with our programming, we should install Rstudio first, right, in our system. So that's very important that you first go ahead and install the R program in your system. So you just need to follow this particular link and just get there, land in the landing page. You will find that Rstudio can be downloaded for free of course. It's open source and it's 100% free. So once you click on that and do the necessary things, and this gets downloaded in your system, and if you click on Rstudio icon on the desktop or wherever you stored it, you're going to get the first window like this. So you will get 4 different windows, and this is going to be the opening screen for Rstudio. So on the bottom left area is where you will write your codes, and on the bottom right area is where you will get to see your charts popping out, and also if you ask for some help, all of those things are going to come and sit on the right bottom window. Okay, so before we start coding and get into ARIMA, there are a few packages you will need to install in your Rstudio for all the functionalities to work, which are required for conducting the ARIMA analysis. Okay, so just look at these packages, what I'm showing currently: ggplot2, funit roots, forecast, t-series, and urca. These many packages you will need for you to successfully complete the ARIMA. Bare minimum packages what you would need to install in your system. So what I'm going to do quickly is to show you how we would give that command. So if you are able to see my screen now, you can very well see that what's the command we need to use. So I'll show you just a quick one. So you just need to type install dot packages and then put the package you want. So I'll go ahead. So the first one what I showed was forecast. So I just need to type forecast and then hit the enter button. So that's going to take, and that's going to go ahead and install forecast for you. So just wait for R to complete the installation, and then the cursor will be back. And once you install the package, you need to run this command require. That is, when you need that, right, you got to basically call for require forecast. That means yes, you have installed it, now I need it. So R is ready to use the forecast. So all the commands, all the functions you write within this package will come automatically when you start typing on the screen, right? So that's how you go ahead and install your packages. And if you, as I told you, you got to do, we just did it for forecast, you got to do it for two T-series, URCA, ggplot2, and funit roots. These are the packages you will need to basically install. So that's about the installation. Okay, now let's get started. The first thing and the most important thing is to set directory for your R. Even before you could start off with any analysis, be it ARIMA or anything, you need to basically show R where is the location in which you are planning to store your data set, right? So then you can call that data set from that location. If you name that location, if you type that name, R is going to search that location in your computer and fetch that data for you, right? So very importantly, that is to be done. So I'm going to show you how to do that command. So this is set WD, set worked. So S should be small letters, it's in caps. You have to disregard and put that in lowercase. So SWD and mention the location, right? And click enter. So that will set the location in R. And then if you want to confirm whether R is got really, you just need to go ahead and type it as GETWD, get WD, and press enter. So that will show up where exactly the location is, right? So, and then, so all I need to do is set directory. So I'm going to just show you how to set that directory. I hope that you can see my screen. So I'm going to go set work directory, okay? And work directory. So I need to be very clear where I'm planning to keep this data, right? So I'm going to open my computer, right, in the folder section. So this is where I'm planning to keep my data, tractor sales. So I'm just going to click here. I'm going to show my video. 1 second. I hope that you are able to see this. Folders. Okay, so I'm going to get my path from the location. Okay, so I'm going to go and just copy paste that location in here, right? So it is the only thing what you really need to focus here is that your R always take only forward slashes. It cannot have backward slashes. So you're going to put the forward slashes instead of backward slashes. And then have inverted commas done for you, and then that's it. Hit enter. So you are all set. Now to confirm whether R has really got it, what you meant, just put this command and hit yes. So you're getting confirmation that I understand this is where you are planning to keep the data, right? So now that you know the location, the next thing is to show R, which is the file you are referring to. So what is the command you would use for that? It is a very simple command. As I've shown you in the PowerPoint, it is, you're going to name it, right? I'm going to name that command as data, so that whenever I want to recall that data set, I just need to type data. I don't need to repeat the command. So I'm going to put this as data as the name, and then read.csv, right? This is read.csv. Read.csv, and I'm going to give the file just forward slashes, and then very importantly, what is the name of my file? So it has to be same. I cannot change the caps or the order or anything. I have to exactly print the name, tractor or sales.csv. This is a CSV file, right? So I'm going to go ahead and tell R that this is the file you will need to refer to. So when I need this file again, I will just type data. So if you want to validate, just type data and click enter. That's going to bring in the file for you, right? So you have already given the work directory. you've confirmed it with get work directly command, and now you've already told R where the data set is, right? So far so good. So the now next task is to convert this data element what you have in this matrix form to a time series format, right? So time series format is required for you to do your time series analysis. So how do you do that? So I'm going to again call data. This is the command what I will be using, right? So the command is going to be exactly data right. This is the command I'll be using. So data, and I'm putting time series, and then data, it's the matrix, right? And in the second row, this is the serial number, this is the first column, and this is the second column where I've got the data. And then I want R to construct a column which talks about 2003. The first point will be 2003, the data, and and January, and the frequency is going to be 12 years. So I'll need 12 years data, and frequency of both are going to be 12, right? So if I want to see what Minitab has done for me, so data, I'm just gonna check whether I've got it right. Yes, I may have got it right only. Okay, so there is a copy paste error, so I'm just going to type it again, data, right, and time series data, comma 2, then start equals create 2003, and it should be starting from January, and frequency is equal to 12. So the data is set for you. So if you want to validate it, just type data and click. So now it has converted that into a time series data where you have got 12 months, 12 years and 12 months data, and you have got the corresponding values there. So it is a time series data, and it's already been converted, right? So this was the job basically, to get to a point where you have got the ready data available to do the analysis, right? So the next task in front of you is basically to decompose this time series and study in detail what are the different components. If you remember my previous videos, we did discuss that there are mainly 4 components, right? There is a trend component, cyclical component, seasonal component, and an error component, or an irregular component, or a random component, right? So what we are going to do now is to decompose our time series, right? This time series I want to decompose and see that. Okay, so what is the command I generally use for it? It's very simple. This is the command. I'm going to show you the command. I'm just going to print that command for you, right? So it's decomp. I'm just named it as decomp. Decompose is the command which is already available, and I'm telling R that this is the data set what you need to use. Type is multiplicative, has to be a multiplicative model, right? And filter is equal to null, means I don't want to apply any filters, right? We did discuss about in our previous videos about multiplicative models and additive models, right? So looking at the data, you need to take a call what kind of model is, but this data is definitely a multiplicative model. So we are asking type is multiplicative and filter. Okay, now if you really want to see plot, if you want to see the graphical image and the details of your time series, you just need to put this command plot decomp, right? It will come. So decomp, right? If I click, this graph is going to come, right? And this is a very important graph what you see here, right, on the right side. These are the major components, right? We were talking about. There's a random component, there is a seasonal component, there is a trend component, and this is what is observed. So if you remember, the multiplicator series impact is like, the constant, the variance won't be stabilized, as the time moves on, the variance also increases. So it is a multiplicative effect. So hence we chose that it's a multiplicative model, and there is certainly a trend element you can see here, and then obviously a 12-month clear seasonality is being put in this data, and then the random component. This is something what we can't really forecast. Okay, so these regular components can be easily forecast, right? And you can really come up with a good forecast number for your process. Okay, so far so good. Now that you know all the components, now the next step or your task is to get your data stationary. Now is the data stationary? No, right? It is under the influence of trend, it is under the influence of variance, and it has a problem of non-stable variance, right? So all will shift the means, right? The trend will shift the means, the unstable variance will shift the means. So you have to go step by step and get your data to a stationary position. So first and the foremost task is basically to get your data from an unstable variance perspective. You want to make it stable. Let the variance be there, but it has to be a stable variance across time. So what, if you remember in my previous video, we did talk about, one of the method what we will use to get the data series when there is an unstable variance, right, is to apply logarithm to the base of 10 to the raw data. So how do I do it? The command is very simple. We'll go ahead and use this command what I'm showing now. I'm naming a variable, it's called a stabilized variance, and I'm applying logarithm to the base of 10 to that data. You just need to type this and click. So now the variable is formed in the name of stable variance, right? So stable variance of log 10 has been already introduced here. Now the next step what you really need to do is, if you want to see how the data is looking like, you're going to look at stable variance and just plot stable variance. So this is going to be a stable variance, right? You are having stability in terms of your variance, right? And it is stable now, but it is still under the attack of trend. So if you ask me a question, is it a stationary data? No, it is not, because the means are changing as through the time. So from a stability perspective, right, it is a stable variance now. It's not an unstable variance. So that's what you have done. So the next task is to get it really stationary from a mean perspective. So you have taken the log, and you have taken the stability. Now let's take a one level difference, right? A one level difference to make the data stationary of the logged one, right? So how do I do it? I can easily go ahead and take a difference, but in case if you want to really look at statistically, whether do I need to take differencing or not, whether my data is stationary or not, right? You always have a code. It is always good to use and statistically validate it. So I'm going to show you how to do it. This is the code what we generally use. This is called as KPSS unit root test, right? So I have basically KPSS unit root test has been done, okay? And then when I click it, this is the command what I have used, that is ur.kpss test, and I'm going to test whether my logged data, that means my stabilized data, is under the attack of trend or not, right? So I'm asking R to account it for a constant mu, that is a trend, or using a regression equation, can I remove the trend from my data? It's the option given, and the lags can be a short lag, long lag, or there is no lag at all, right? Short lag means to the order of 1 or 2. Long could be longer lags, and there may be no lags applied also. And use.lags is equal to null, and I'm asking for now you don't consider any lags, right? So null is the use.lag. Null is basically what I'm asking there. So if you really want to see how the test has been carried out, you just need to type summary, right? And then put un. I have named the test, right? unr. Yes, now it has popped up, right? And this is going to give me the value, right? So what is more important here is the test statistic, right? Test statistic shows that 2.7416, right? And at the 5%, my critical value is 0.463. So this value is way bigger than this value. That means it is coming in the less than 5% shown, right? So if it is less than 5%, if the risk is less than 5%, I will go ahead and reject my null hypothesis. This test, null hypothesis, the data set is stationary, and the alternate hypothesis is that data set is not stationary. So I am forced to take a decision that the data set is not stationary because of the p-value, right? Because of the significance of this test. So you have done this test just to ensure that whether I have a significant p-value or not. So it is a significant p-value, and I have to reject my null hypothesis, leaving with a statement that my data set is not stationary yet, right? This is just an add-on step which we have to statistically validate it. So my next task is to get this stationarized. So the first thing is I'm going to do is to take the difference, right? So how do I do that? I just put this command in place, diff log. That means I'm just naming it as difference of log, and then I'm putting a difference command here, difference, and state variance. That means the variance has been stabilized here, and I want to comma 1 is the difference what I want to take. That is one difference, the first order difference, right? So then if I I'm going to type this once again. There could be diff log difference of stab var, comma 1. Okay. So if I have to plot diff log, how is it? So look at this. You can see the screen now. What you can see on the screen currently, you see that the variance with an upper trend data has been, the trend has been removed, and the data looks more or less stable now, right? Because the mean is going to be a consistent line across, right? That is very important for us to proceed with our ARIMA. Its basic first condition is to make the data stationary, right? Now I see that the data is fully stationary, right? Do you want to statistically validate it? How do you do it? Very simple, right? You have already done the test, kpsS test, right? You can repeat the test. You just need to go back to that command. Instead of step var, I will use diff log, right? So diff log, and I'm going to call summary of un RT. So look at it. So my test statistics is 0.0248, and whereas my 5% statistics is 0.463. But this is way less than my 5%. That means this is beyond my 5%, right? The risk what I will be taking in rejecting my null hypothesis is more than 5%. So I cannot reject my null hypothesis. So what does that my null hypothesis say? My null hypothesis say that my data is stationary. So because of the significance of test, we cannot reject the null hypothesis. We have to accept it and accept the fact is this data set has become stationary, right? So that's a quick text. What you can do, KPS is very handy test. You can do that to validate it. And now we have validated that assumption that our data set is stationary, right? So now is the most important task, I would say, right? Now we have got the data set stationary. Now you need to identify what are the components, right? So differencing component you have identified, right? By differencing and by taking a difference of 1, you say that you can make your data set stationary, right? Now that has become stationary, the next task what you will need to do, how do we want to do it? So the next task was all about identifying the AR and MA components from this data set, right? The D is already identified, right? We have taken one difference. So now we need to identify P and Q. How do you do it? The only way manually to do it is to create the ACF and PACF plots. What is ACF plots and PACF plots? We did discuss that in our previous video. So ACF is autocorrelation function. PACF is partial autocorrelation function. So let's look at how we can apply the ACF and partial ACF commands, right? So ACF, where are you going to apply it? ACF is you're going to apply on the diff log data, right? So if you apply it on the diff log data is where you will get to see what are the components available, right? So let's look at it this way. I'm putting the command ACF time series diff log data. Okay, now I got that, and then I will do the PACF. I got the PACF also. So now we have to look into this particular graph to take the final decision as to how my data is looking like and what could be my potential model, right? So to make it easy, I have a command which you can very easily use to put this in same order, right? It is in one after the other, right? So if you want to put this in one order, you just need to use this command, right? PAR MFROW C12, and then I'm gonna use my ACF and then PACF. So it has come side by side. So now it is very easy for you to look at, compare and take a call. So if you remember, for a AR model to be existing, this should be declining in an equal rate and it should be approaching zero. But here it is obviously zero. I'm going to disregard, but after the first lag it is all cutting. So there is typically no AR model here, and what I can see here is some sort of a truncation, right, which is forcing me to believe that there could be an MA model with an order of 1, right? One component is good enough to talk about the MA component of this. So here what has happened is that we are looking ACF on a diff log data. If you want to be a little more specific, you can even go ahead and do this in your stabware data, right? ACF in a stabware data, right? And PACF in a stabware data. But the reason why I did not propose this, in the ACF data, if you really look at it, this is not at all a stationary data, right? There is a strong seasonality here, right? So if this may not be an ideal way to look at it, so this is an indication what it gives you to go ahead and stabilize the data or to make the data stationary. So this may not yield you much of a result. Rather, we would stick with this, and with this limited term we will get to see that there is no AR term, there is only an MA and a D term. So one differencing we have taken, so D is equal to 1, MA is equal to 1, and that's obviously there is a strong seasonality. So a non-seasonal component, and it will have a seasonal component as well with the same components, that is 0 as AR, 1 as difference, and Q as moving average 1, right? So that's the best assumption what we can make out of this ACF and PACF. I know that it may get tricky at times, it may be very difficult for people to follow this. So ARIMA package is giving you one good auto fit command. That means you can avoid all these confusion, and you can just simply use this command, right? So that command, if you apply that command, And then if I ask the output as, look at the model, right? So the model is again suggesting there is no what we just discussed, and you know, this is what is it going to look at is the least BIC values, right? So these are the AIC values. So 702 is the least value what I got, right, from a AIC perspective, and this model is chosen as the best model. So what we have looked at from a manual perspective, I'm also trying to get that assurance through the ARIMA model. So the ARIMA is also throwing up saying that okay, this should be the best model what I'm using, right? So if I'm typing ARIMA fit, this is going to give me this result, right? The best model. Stab variance, I have done that, auto ARIMA fit. It is telling me that, you know, you need to take one difference and you need to consider for a term in 1, which is a moving average term, and it's a seasonality component and 12-month seasonality. AICC component is 702.6, which is the least. Okay, so that is how you can, with one command, using this command, right, auto.arima stab where trace is equal to true, it is going to iterate multiple times and going to give you a best ARIMA model with the least AICC value, and that's exactly what this auto.arima function is going to give you. This function is very important. Okay, so just be very clear in terms of which to be used at what point. So this function is going to give you maximum advantage or saving time, right? What you can see here, the ARIMA, what I have highlighted now, this is the important function. Okay, so now that you have identified which model to be applied, now it's time for us to go ahead and create the forecast which is required, right? So how do we get the forecast? So first to get the forecast is that, you know, I have to use these terms, right? So the first command what I'm going to give is this, that I'm going to create a variable called pred, which is going to predict using the best fit what I have given, n dot ahead is equal to 36, right? So 36 more data points I want to predict. So it is already predicted, right? So I'm gonna pred, okay. So that would have already been predicted now. I'm just leaving it, I'm just continuing with the program, and I want that prediction to be a blue line, right? One second. Before that, sorry, I need to bring in one component which is a very important component. Yes, okay. So I'm asking to plot the original data, right? Type as L, and the x-axis should have values from 2004 to 2018, and y-axis should have values from 1 to 1600 tractors sold. X label should be year and Y label should be tractor. Okay, so that is already plotted in here. So half the work is done. So now I'm going to talk about the forecast, right? That is where I will have this command coming, right? I'm going to use this command here. That means I want the forecast to be in blue, but in this command, if you look at it, I have used lines, so this is going to generate the additional lines here. But stabware is a logarithm of the original data, so you need to bring that data to the original series. So that is why you are raising that particular thing 10 raised to predict $predict That means you are raising the predicted value to the power of 10, and then you are asking R to give you a blue color for that. Okay, so let's see what's happening. So you got to see, right, on the screen now, what you can see, there's a blue color got added. This is the forecast, right? But now, are you happy just with that? No, I want to create two more conditions to it. That means I want to introduce my confidence intervals, right? I want to twice my standard error to on top and twice my standard error down. So I'm going to give this command here, what you can see here, right? I'm going to ask +2 times the standard error on top, right, twice. So that's going to give me an orange line on this. This is the upper confidence level, and similarly I want to build the lower confidence level, right? So how do I do it? I take lower confidence level, just apply this, and I'm going to put that as minus. How do I do it? I'll just do this and take a minus here, or instead I can change this whole thing and replace this with orange minus, right? So I'll see I have a lower confidence interval as well, right? So now my forecasting is completed. So if you really want to look at what is the value, right, of that forecasting, you just need to call for this command 10 raised to predict $predict, right? So these are your basic forecast starting from January 2015 to December. This is the value what you see in this blue line, okay? And the next task for you, now that you have created your model, right, from this model, if I take the residuals, right, from the predictions what I've done, if I take the residuals, then it should not have much of additional contents, right? So now I'm going to do the ACF and PACF plot for my best fit ARIMA, right? So this is the ACF time series ARIMA fit and its residual. So I have already generated a forecast using this, and I want to check how my residuals are going to look like. So just hang in a second. ACF time series ARIMA fit residuals, right? So that is good. And if you remember the command what I have given you, you can use this command to get the data alongside, right? So I will put ACF, and now I want PACF for the same. So I'll add a P here, and let me see. Okay, so what is important in here is to basically look at whether all your lags are within your statistically significant limits of upper and lower. So that means there are no more information available in this fit. You have extracted maximum, and the data, the residuals look to be random. So for now, you have a very good statistical ARIMA model in your hand, and you know what is the ARIMA fit for that. That is 011 011 with a seasonality of 12. If you predict, you are going to get a good model with the least AICC score of -702.36, which can be used for your prediction. So I hope that you could follow the video, and this is very simple, and I have this documentation. I'm going to show you on the screen now how we have done this in PowerPoint. So in PowerPoint it is very simple. I'm going to run through that through slides, right? You can see this, right? So in PowerPoint, what you're going to do is to install Rstudio and put your packages in place. Install all these packages. Please note these are the packages required. I hope that you have noted it. And now first thing is to get set work directory. You did set it, and then to validate it, get WD. Then you will get to see this popping up, and then you are telling R where your data is stored and what is the file name, and then that is getting stored in data. and then this you have converted this into a time series data. This is the command what we used. And then once you convert this into time series, you're asking R to decompose the data, and these are the decomposed data what you have got. You validate that you have a trend, you have seasonality, and you have a random component. So hence you are confirming that the data is not stationary, right? So for you to bring this phenomenon of unstable variance to a stable variance condition, you are taking the logarithm of the original data time series and naming it as tab variance, right? And then plotting it, and you get to see that your variance instability is being solved. However, you have a trend. The data is still non-stationary. So to prove that statistically, you did use this KPSS test, and you named it as RTST, and then when you call the summary, you will get this result. And why you are saying that this result is statistically significant? Because your test statistics is more than your critical value, so that means it is less than 0.05. So you go ahead and rejected the null hypothesis, and you concluded that the alternate hypothesis, that the series what you're testing is not stationary. So to make it stationary, you went ahead and created one different diff log, another variable, and you took the difference of the stable variable and got it one difference, and then you found that you got a stable variable, right? And then what you did is you went and you took the diff log data and you did the ACF and PACF, and you found that the ACF and PACF. From the ACF and PACF, using the clues what we discussed before, we estimated this could be perhaps the model which can be used. So to validate it again, you did auto.arima. You took the stabilized data and then trace is equal true. So again, Arima is also telling you that go for this particular model. This could be the best model. So that's how we have concluded it. And then finally you predicted that Arima fit you have taken. This is the best fit that you have put in is the variable you created, and you asked R to predict N forecast ahead. So here the only thing what I want to say is that there is a small correction. N dot ahead is equal to 36. That's how you should read the command. N dot ahead is equal to 36, and then it is asking you to, then you are asking R to create till here with this command, right? 2004 to 2018 and 1 to 1600. You are asking the command, and then finally here should be your x-axis and y-axis should be tractor sales. And then you are giving additional command to change your predicted value from a logarithm base to a normal, right? You are changing, you're transforming it to the original data. That is by taking 10 raised to that power, and that's how you created the blue line, right? And then 2 times your standard error, you are multiplying it with your prediction. That is your upper confidence level, and -2 will become your lower confidence level, and it is becoming orange. You just use this command, type this in R so that you get the values also. You can visually see these are the values you have forecast, right? Finally, you are using that best fit and $residuals. So this is going to generate the residuals for this Arima best fit, and you are plotting the ACF and PACF. What you really need to ensure that when you plot the residuals of ACF and PACF after modeling, all the bars except the zero will always be outside, because this is the zero lag, means the same variable is getting regressed with the same. So obviously you will have 100% fit. So you disregard this, but starting from first lag, all of them should be within your statistical significance limit. That's the blue line. So that means the data is totally random and there are no more information to come out, right? And this is how you finally conclude your Arima using R. I hope you understood the video. Again, if you have got any doubts, please drop an email at info@trainfirm.com. I know that some of you have reached out to me and I have given replies to you as well. So if required, we can also have a one-on-one in case if you have a critical doubt. We can get onto a WebEx and solve it. I hope that you enjoyed the video. Happy learning, and please do try Arima in your projects as well. Very effective tool, and R has made your lives really easy as well. Now that you have both Minitab and R, please keep using it and let me know how it feels. All right. Thank you so much. Have a great day ahead, and I'll talk to you soon. Thank you.